Assalamu alaikum. Welcome to NAD University. This is IEEC session 1. Can you confirm if you can hear this and uh, if you can check your camera as well? Uh, if you can check your camera as well.
व्हाट्सएप पे बात कर रहा हूँ कॉन्स्टेंटली, लेकिन ज्वाइन तो मैंने कर लिया, लिंक मैंने व्हाट्सएप पे भेजा इनको।
Uh, if you can check your camera as well.
बात करेंगे तो आवाज़ आती है, लेकिन ज्वाइन तो मैंने कर लिया, लिंक मैंने व्हाट्सएप पे भेजा इनको। ये उन्होंने ऑफ किया।
If you can check your camera as well.
बात करेंगे तो आवाज़ आती है, लेकिन ज्वाइन तो मैंने कर लिया, लिंक मैंने व्हाट्सएप पे भेजा इनको। ये उन्होंने ऑफ किया।
If you can check your camera as well.
बात करेंगे तो आवाज़ आती है, लेकिन ज्वाइन तो मैंने कर लिया, लिंक मैंने व्हाट्सएप पे भेजा। जी उनको आ रही है। जाहिद साहब आपको आवाज़ आ रही है हमारी? ये उन्होंने ऑफ किया।
If you can check your camera as well.
Testing. Hello.
Hello, Assalamu alaikum. Zainab binti Muhammad Zain, can you hear us?
Yes, I can hear.
Ya, selamat datang ke conference ini. Apa kabar?
Terima kasih.
If you can check your
Baik,
camera as well.
Alhamdulillah. Testing.
Alhamdulillah.
Hello.
So shortly we are going to start. If you're ready. Hello, Assalamu alaikum.
Uh,
Start off with your presentation. Zainab binti Muhammad Zain, can you hear us?
Okay. Yes, I can hear.
Ya,
If you
selamat
haven't
datang
already
ke
used this, there is a button to
conference ini.
share your screen.
Apa
The
khabar?
button is in the
Baik,
present now
Alhamdulillah.
button.
Testing.
Click on that and you can
Hello.
share your
So
screen.
shortly we are going to start. If you're ready. Hello, Assalamu alaikum. Start off with your presentation. Zainab binti Muhammad Zain, can you hear us?
Okay. Yes, I can hear.
Ya,
If you
selamat
haven't
datang
already
ke
used this, there is a button to
conference ini.
share your screen.
Apa
The
khabar?
button is in the present now button. Click on that and you can share your
So
screen.
shortly we are going to start. If you're ready. Hello, Assalamu alaikum. Start off with your presentation. Zainab binti Muhammad Zain, can you hear us?
Okay. Yes, I can hear.
Ya,
If you
selamat
haven't
datang
already
ke
used this, there is a button to
conference ini.
share your screen.
Okay,
The
my
button
name
is in
is
the
Zainab Muhammad Zain on behalf of
present now button.
Ina and Sundar. We are from University Malaysia Pahang,
Hello, Assalamu alaikum.
Previously known as
Zainab
University
binti
Malaysia Pahang.
Muhammad Zain, can you
So
hear us?
today we will present our project
selamat datang
as a
ke
broadcasting driver
conference
safety
ini.
for real-time eye detection for drop incident prevention driver assistance system.
Present now button.
So basically in Malaysia, University Malaysia road accident is one of
Hello, Assalamu alaikum.
the previously known as
Zainab
University
binti
Malaysia Pahang.
Muhammad Zain, can
For
you
the
hear us?
dates of the today, we will present Malaysia. So in
selamat datang ke
I'm sorry, madam, but we are still unable to watch your screen. We can see your browser, but there is no presentation.
In Malaysia, University Malaysia road accident is one of
Hello, Assalamu alaikum.
the previously known as
Zainab
University
binti
Malaysia Pahang.
Muhammad Zain, can
For
you
the
hear us?
dates of the today, we will present
selamat datang ke
I'm sorry, madam, but we are still unable to watch your screen. We can see your browser, but there is no presentation.
relevant window of your screen
Hello,
that you
Assalamu
will
alaikum.
try to share
This
everything
is
and just open
Zainab
the
Mohammed Zain
presentation so we could see it now.
uh,
Right now we are not able to see anything other than your Meet, Google Meet.
uh, okay, stop. Show entire screen. Okay. Okay, now you can see the slide now.
That's,
Oh,
yes, now that's better. We can see it now.
okay. Thank you. Okay, I will start again. Okay, we are from University Malaysia Pahang, Al Sultan Abdullah, or previously named University Malaysia Pahang. So, I am Zainah Muhammad Zain. On behalf of my team, Muhammad Syahril, Rosina, and Samsyah. Okay, I will present a paper entitled Enhancing Driver Safety Real-Time Eye Detection for Drowsiness Prevention Driver Assistance System. So basically, this project, the idea is coming because of the problem in Malaysia. They have a lot of road accident, and then some of the causes is due to the drowsiness of the driver. Has reported in the MIROS, Malaysian Institute of Road Safety Research, in 2022. There were a total about more than 500,000 road accident reported, and for average around 1,494 accident per day. So this is quite a big number that caused the deaths in Malaysia. So compared to 2021, so there are increasing around 47 percent. So actually around half percentage of increases in for 2022. So due to this problem, okay, based on literature, we found that drowsiness of the drivers of the driver is the one of the main factor that cause to the road accident. Therefore, as we see for the current literature, some of the drowsiness detection system, they use high technology, and also for the not a new car, so they are expensive to buy the system. So as the solution, we plan to develop a portable eye detection system that can detect the drowsiness driver for driver assistant. So this is actually what we have done. So first, we develop eye detection system that will automatically detect the eye of the driver to make uh, identify the driver is in a drowsy condition or not, and then to integrate that the developed device into a car. So this system not only can use in a new car, but also can be used for the old car. So, and the third one, okay, we analyze the system to see the performance and the effectiveness of the system. So because this is the first time, or we can say that this is a prototype one. So the in the design, we have some limitation. For example, the device must be a small that can be easy to use by the driver, and then we also only use a buzzer to alert the driver, and also we use a low cost camera for the detection, for image detection. So this is some of the literary review that support to our methodology. So basically for the detection, most of the previous researchers use the controller Raspberry Pi, and some of them use the camera BI no infrared sensor that integrated with the Raspberry Pi. That is the main electronic or detection system that must have in our system. So for the classify system, we use hard cascade system for the image processing features. So we distribute our methodology into four phase, which is phase one, design the concept. Phase two, the selection of the component and software identification. And phase three, integrate the developed system. And then phase four, development of prototype and analyze the system. So basically, for the design concept has mentioned previous. So the main electronic part that we use is the Raspberry Pi for the control. Has a main controller that we integrate with the camera. So this is the block diagram of the system. When we detect the driver, we classify the driver in a drowsiness stage. So the controller will capture the image and then process the image, and then will alert the driver if they are in the drowsy condition. So phase two for the component identification. So we categorize into two part: hardware selection and software selection. For hardware selection, this is the hardware that you use. We use Raspberry Pi 3 Model B Plus, and then PI Noir camera board version 2. Also, we use TFT touchscreen for display and active buzzer for the driver. So this is about the Raspberry Pi. Okay, this is the schematic diagram for the system. So as we know, we use we use the Raspberry Pi for the microcontroller, and all the input output of the system is connected to Raspberry Pi. So this is the wiring diagram for Raspberry Pi and the camera. So for the software, we use OpenCV. Okay, this is a free software that we can use. And then this is about the software selection. We use a HA algorithm, okay, for features used in object recognition. So this is some of the information about the HA cascade. This for the HA cascade algorithm, this algorithm used in many projects which is based on object recognition. And then this is the D-library shape predictor that used for landmark detection. So to identify, to classify the driver in a stage of drowsy or not. So I expect ratio atau or ear algorithm is used to calculate in what percent the eye close or open, so the driver's condition is categorized in drowsy or not. So, and then for the integrated system, after we start with connect Noi camera to the Raspberry Pi, and then install the software OpenCV with HA cascade to detect face in image, to detect the image, and then install the delay into Python environment, and then when the image is applied, and then delete facial landmark, okay, will apply to obtain 68 silent points, and then the system will detect the eye of the driver, and then it will produce the alarm or notification based on the eye detection.